So that's our question. We have an LC oscillator like circuit, and here we have a special member in our circuit. It is an ideal diode. The okay. So what is in the question? So the value of the capacitor is given in microfarad. Value of inductor is given 1 millihenry, and the diode is ideal. The capacitor is initially charged to 10 volt. So the capacitor is initially charged to 10 volt, and the current in the inductor is initially 0. Okay. If the switches is closed at t equal to 0 second, the voltage VCT across the capacitor at t equal to 0.5 second is. So we have to find out the VCT at 0.5 second. I think we can do that, right? So here is a diode. First we have to know what is the property of a diode. This is P side, this is N side, right? If the voltage of P side is greater than N side, then the diode will be in short circuit mode if it is ideal diode, and if the voltage of P side is less than voltage of N side, then the diode will be act as open circuit. Or simply we can say when diode is on, then current will flow through the diode. When the diode is off, in this case diode is on, in this case diode is off, then there will be no current through the diode because it is act as open circuit. So if we assume that the diode is on, we can make this circuit like this. Okay. Make this diode like this, and this is L0. So if this is V0 at first, this will be also V0, and if it is V0, the current will be flow like this, right? It is V0, the current will be flow like this, and here it's our open, so the current is flowing from it in this side. In this side the current is flowing, so our assumption is correct. So if the current flows this direction, the diode is on. If the current flows this direction, the diode will be off. So in our case the current is flowing in this direction, so our assumption, which was diode on, is correct, right? So what I can say now, I can say that if we consider V0, then we will find out that the IT at 0 plus will be 0, as the I0 is given in the circuit is 0. The IT at 0 plus will be 0 because the inductor will tend to keep its current constant, right? IT 0 plus equal to 0, and at steady state IT infinity equal to also 0. Why? At steady state the capacitor will be open circuit, and then no current flow through this circuit, so that's how the inductor will be open circuit and IL infinity equal to be 0. So it is open circuited, right? So what we know, who follows this equation, that 0 at the starting and 0 in the finishing, who? It is sine, right? So the equation of IT will be ILT, it will be sine omega naught t, And what will be the value? Value will be what is charging it or discharging it. Is it charging or discharging? In the I not ILT is this side and V naught is charging it. So the value will be V naught by root L by C. So it will be V naught root C by L sin omega naught t ILT. Sorry. So now you can see that this ILT equal to V naught root C by L into sin omega naught t. So if you people are don't know how I have got the sign thing here, so if we look if we look closely at the sine function, that at t equal to 0, what will be the sine value of sine? It will be 0, right? And at steady state, at infinity, what will be the value of sine? At infinity mean the average value of the sine. What will be the average value of sine? This is the average value. Average value will be 0. So the initially it is 0 and at steady state it's also 0. So that's how we got it. And from here we can get the VLT as well, right? If we can get the VLT as well, how we can get? We know L di upon dt, right? So V naught root C by L or V naught root LC and the integration of it. What will be the integration of it? Cos omega naught t upon omega naught. Omega naught is 1 by root LC and here is also LC. So without this VCT we can directly write from the equation, right? So from at t equal to 0, VCT is V naught and at t equal to infinity, VCT is equal to 0, right? So from here we can see this type of behavior, means at starting point there is some value and at steady state it is 0. It is cos initially, cos omega naught t, and omega naught here it is coming 1 by root LC, which is calculating 10 to the power 4 radian per second. So we got ILT or IT and VCT, right? Right. So now if we draw ILT and VCT, okay. If I draw this, then we can find out that after this certain amount of means pi time, that the I is going negative in its, which is not desirable, because if I direction of I is will be negative, then the diode will be turned off. Sorry. So if the diode will be turned off, then the inductor and the capacitor will be separable, and we will get something like this at t equal to pi, or we can say omega naught t equal to pi, t equal to pi, and t equal to pi by omega naught, which is 0.314 millisecond. Okay, so at 0.314 millisecond, we are finding out that the current is going opposite side. So that's where the VCT will be stuck, and it will not change its value after that point, and the current here also will be stuck and not change after this point. So after this point, ILT will be like this and VCT will be like this. This will not be there. So VCT here is minus 10 volt and it is here 0 ampere. So that's our equation, and that's our solution. Thank you.